Let's practice adding and subtracting complex numbers together. For number 1, notice right away that we are adding two complex numbers together. So if we're going ahead and doing that, what's nice is we can just go ahead and drop the parentheses. They don't make a difference when we are adding. So let's just go ahead and rewrite this expression all in one sentence here. And let's just go ahead and see if we can combine like terms. We typically will start with the real part. So 4 and 5 are real. So 4 plus 5 is going to equal 9. So combine those like terms. And then we can go ahead and combine this 2i and negative 3i. So 2 minus 3, that's going to be negative 1. So we can write minus 1i or just minus I. This would be the simplified expression here. Okay. For number 2, let's see, we are adding again, so we can go ahead and do the same thing where we drop the parentheses. They don't make a difference, so that's negative 5 minus 4i. We have plus a negative 6. I'm just going to give that negative 6 a hug to keep it organized, plus 9i. Okay, so the real part here is negative 5 plus negative 6. That's going to be negative 11. And then for the imaginary parts, we have this negative 4i plus 9i. So negative 4 plus 9 is positive 5. So we're going to write plus 5i. Okay, so this would be our complex number written in standard form, and it's simplified. Okay, moving on to number 3. Notice here that we are actually subtracting in this case, so it's important to make sure we keep that in mind. So we can just keep the 7 plus 3i in the first parentheses, but keep in mind that there is technically an invisible 1 here that's in front, so we're going to basically multiply negative 1 or distribute it to both terms here, and that's going to flip everything. So negative 1 times negative 3 is going to be a positive 3, and negative 1 times negative 6i is going to be positive 6i. Okay, so make sure with the minus sign we flip everything in the second parentheses before we drop them. Then the real part, 7 plus 3 is going to equal 10. And then for the imaginary parts, 3i plus 6i, that's going to equal 9i. Okay, so this right here would be our solution, or our simplified expression rather. Okay, moving on to number 4. We have another minus sign here, so let's make sure we do the same thing we did in the last example. Let's take this negative 1 that we know is here and distribute it to both of these terms in the second parentheses. So we have negative 4, take away I, and then we have a minus 5 and then a minus 3i. All right, we got to flip the signs of both of those. Now, negative 4 minus 5, that's going to equal negative 9. And then if we take this negative 1i and take away 3i, that's going to be negative 4i. Okay, so this would be our simplified expression here. For number 5, let's see here, we have a plus sign, so we can go ahead and just drop the parentheses and not worry about anything. Distributing a positive 1 won't make any difference, so we're going to go ahead and just copy that down. Okay, now that we have everything kind of separated here and no parentheses, this negative 8 plus 4, that's going to equal negative 4. And then for the imaginary part, we have 9i take away 5i, so that's going to be plus 4i. All right, so that would be our expression written in standard form. Here's number 6. For number 6, we do have a minus sign in between here, so we are subtracting. Let's make sure we go ahead and distribute this negative 1 to both of these terms. That's going to flip them. So rewriting these without parentheses, let's have negative 7 plus 4i, and then positive 6 or plus 6, and then plus 3i. All right, so let's go ahead and combine the real part. So negative 7 plus 6, that's going to equal negative 1. And then for the imaginary parts, we have positive 4i plus positive 3i. So we have 3 plus 4, that's going to equal 7. So we have plus 7i. This would be our standard form for the simplified expression. Okay. For number 7, we have another minus sign in between the parentheses here. So let's take this negative 1 and distribute it to both of these terms. We're going to flip the signs of them. So we'll have here negative 3 minus 6i. Then we're going to have a plus 4 and then a minus 9i. Okay. Now this negative 3 and positive 4, we add those, we're going to get positive 1. And then this negative 6i take away 9i, that's going to be a negative 15i, or we can just write minus 15i. This would be our simplified expression. All right, let's check out number 8. For number 8, we have an addition sign in the middle here, so we can just go ahead and drop the parentheses. So we have 5 plus 2i plus a negative 8, give that negative 8 a hug to keep it organized, and then minus 7i. Okay, so let's go ahead and combine the 5 and the -8. If we combine those, 5 plus -8 is -3. And then this 2i, take away 7i, that's going to be minus 5i. All right, so just like that, we have our simplified expression. For number 9, notice that we do have a minus sign here, so this -1 is hiding out here, so that's going to flip this 5 to make it a -5. It's going to flip this minus I to a positive I. So without parentheses, we can write -1 minus 9i minus 5 and then plus I. Okay, so this -1 minus 5, that's going to equal -6. Okay, and then for this -9i plus 1i, that's going to be -8i. So that would be our simplified expression. Finally, for number 10, we have one final expression, but in this case, we have another subtraction. So let's go ahead and take this invisible -1 and distribute it to both of these terms here. That's going to flip them. So without parentheses, we'll have -8 plus 3i, and then we'll have plus 2 and then plus 9i. Okay, so this -8 and positive 2 will combine to make -6. And then we can go ahead and combine this positive 3i and positive 9i to make a positive 12i. All right, so this would be our simplified expression. All right, so there you have 10 different examples where we are adding and subtracting complex numbers, and we wrote all of our solutions in standard form. We have a plus or minus bi, and so you can see here a is just the real value that is in front, and then b is just a coefficient for I each time. So hope you found this video helpful. If you did, please consider giving it a thumbs up, and as always, keep up the great work, and I'll see you in the next one.